Good afternoon. My name is Lalita P. I am going to present the PPT presentation. Yeah, this is my case study. That is, we are going to find a job seeker success prediction using a machine learning approach. So, this is the introduction of our case study. So, the project is we have to find the job seekers like they have applied for the job. We have to find out that how many got placed and how many not got placed. So this is the objective. We are predicting the likelihood of the job seekers being hired based on the historical hiring data. The importance is we are enhancing the recruitment efficiency as well as the decision making of the HR or any head of the company. Then this is the project overview. What we are going to do is we are going to predict the hiring success rate of job seekers using the past placement data. The problem statement is if we are going to manual hiring processes are more time consuming. So in order to overcome this, we are going to find the predictive model in order to assess the candidate success probabilities. So this is the scope of the project. How we are going to predict is we are going to predict whether the person is got placed or not, and we are helping the recruiters to filter the top candidates based on their marks and everything that we are going to see in further steps. And this we are identify the as I told now. Then open questions are the assumptions are like we are using only the past data, and the placement status means result is in binary form. That is, if it is placed means 0, sorry, if it is placed means 1 and not placed means 1, it is binary values. So in binary values we can see only 0 and 1. And open questions are even we are not able to predict that. Either we can use also aptitude scores as well as the interview feedback, like whether the person if we go for interview, he will give an interview, no, based on that feedback and aptitude scores we can consider. And whether we can consider the time based data like year wise hiring trends. And this is the workflow of this project. So first we are going to take the CSV data, like our data set is in the CSV format, and we are going to pre-process. If we have a data set directly, we can't use in our project. We have to do some pre-processing on that. Those are like we are going to remove some columns and we are going to edit few details, so that we are that comes under pre-processing. And we are going for model training. Model training, what and all models we are taking in machine learning is logistic, RF, and XGBoost. Model training means we are training the models in order to predict that based on our past data, we are going to train the model in such a way that it is giving a result in more accuracy. And after that, we are evaluating the accuracy F1 and ROC, and we are going to save these models. And finally, we are getting the ROC or feature plots. And these are the technologies we have used in our project. Those are like Python. Python means our language. What I have used in this program is Python I have used, and Pandas and NumPy for calculation, Matplot and Seaborn for the data visualization, and XGBoost and Joblib. I have run this code in the VS Code. And these are like a source code explanation that I am going to give in the project, that we'll see while running the code. And these are the outputs I got in the terminal that I'll show later. And these are the graphs. So four graphs I got. And the conclusion is like finally we have developed the predictive model with the satisfactory accuracy. And we are going to see that whether which model has reached the more satisfactory accuracy. And this random forest gave the highest accuracy. And important features like CGPA, work experience, and degree type we are going to consider in this model. And model can help the companies as well as the HR to shortlist the candidates. Now I'm going to show how our project will work. I'm going to VS Code. So, so here you can see the, yeah, this side you can see that I have created a folder job seeker success. Under that I have many folders. Under this data we have our data set, and these two are like future, like after running the program we'll get the results, the results will get stored in these folders. And these are some GitHub repositories. And yeah, we'll go for our uh, this one program. So mm, so these are this program is in a Python language. So yeah, these lines are like we are importing some libraries. So as I said before, this pandas and numpy for data handling, and matplotlib and cbom for visualization, and machine learning models are like under these sklearn libraries. And we are saving the models in joblib and os for managing the directories. And this is like we are ensure the necessary directories, like these two lines. What we are going to create, as I said before, these models and results. This is ensuring that whether these two folders are there or not, because after running the program we are getting the results that will store in these folders. Then after that we are loading the data set. So data set means it's under data folder. So here we have CSV file, means that data set that is stored here. We are going to load those data set. And after that what we have is we are dropping the unnecessary columns. What are all unnecessary columns? The serial number, uh, this we are not going to use, like it doesn't make any changes in the result. And salary also, we are not concentrating on the salary of a person, only we are predicting that whether that person placed or not. Then we are encode the categorical variables. So this is like we are encoding the categorical variables, like we are assigning the values for these, like for gender, SSP, this we'll see in our plots. And this is about encode categorical variables. Then we have to define the features and targets, like what and all columns we have dropped. Those those columns will not reflect. Then after that we are dropping these, and X label will tell us about all features. Only expect the target variable, and in y-axis we can see that target variable is there, like whether the person placed or not. And after that we have the train train and test split. Like here we are going to split the test, like here 80% of this having a training and only 20% is having about the testing part. And here we are defining the models, like dot and all we have used that we have defined here. Then after that we are training the model in order to give the more accuracy in the result. These are all the outputs that we'll see in the terminal after running this. Then after that we have a random forest feature importance, like that we have defined here. Here we have defined that random forest one. So after that, so this is about the code. Now I'm going to run this code where we can see the output. So going to run, yeah, here you can see the values. So this is the logistic regression evaluation. So we have accuracy of 0.88, like in percentage if you are saying means 88.3, and score F1 score is 92%, and ROC curve, and this classification report is 0 means whether the person is not placed and 1 means placed. So it has um, precision recall and FN score and support for 0, like that person not placed these values and person placed for this. And random forest evaluation means these value. So by seeing this, what we can tell is this logistic regression has more accuracy compared the random forest, like this model give the more accuracy. So after the running this code, we have got graphs in the result folder. So here we can see that this is the logistic regression ROC curve. So what it is telling is this graph shows the ROC. ROC means receiver operating characteristic curve for the logistic regression. And the AUC, what is the area under the curve is 0.93%, like not percent, 0.93, which is very high. So the ROC curve evaluates the model's ability to distinguish between the classes. So the closer the curve follows the top left border, this is the top left border, so that is like the model is better. So by seeing this, we can tell that the model is better. And next graph is random forest one. So this horizontal bar chart displays which features are more influential in the random forest. So there are top three are SSC, degree and HSC, where SSC is the secondary school percentage and this is the degree percentage and this is the higher secondary percentage. And third one is random forest ROC curve. We have value of 0.87. So the ROC curve of the random forest classifier with an AOC of 0.85. And the random forest model performs well with an AUC of 80.87, while not as strong as logistic regression as we see in the terminal output. And this is the XGBoost. So XGBoost is achieved with a 0.87, showing that it is a robust predictive power and it slightly outperforms the random forest model, but is still bit behind logistic regression in this particular use case. So these are the graphs I got. So this is about my case study. Thank you.